Now that we have a handle on the needle animation, it's time to focus on a different part of the project. And that is going to be our radar system. I want to have the Airsoft BBs replicate the tracking function of the needles in-game. And for that, I'd like to use a pair of 25 gigahertz radar transceivers and compare the signal strength of left to the right and determine if my target moves left or right, and then rotate the hop up accordingly to curve the BBs toward the moving target. Well, sounds like a good plan, but then I remembered that radar does not like to look through metal, and I became concerned about the gun candy coating I plan to put on the shroud of the needler and whether our radar system could see through the gun candy prismatic coating. So I rounded up the magazine section of my carbine, and we're going to use that as our test guinea pig and see if these 25 gigahertz radar units can actually see through the gun candy coating. And if so, then we've got a project. So we start off with zero velocity, and we're pointed toward the ceiling of our outdoor porch area so we get consistent radar returns. And we start our walk. We see a solid velocity about 2.4. We bring up the shroud, and it quickly comes back, so we're getting a good reading until we start to see open sky. So yeah, the radar can see through the Cerakote. Looks like a go for this project. Now, one of the other problems with these radar systems is they have a field of view of 180 degrees or so. So that means that most everything that the left radar can see, the right radar can see as well. And they can see my BBs leaving the gun, which will cause a stray reading. So I bought a few pieces of radar absorbent material. This is silicone rubber that is saturated with iron, and that absorbs signal so we can block off what the radar units can see, kind of like horse blinders. And hopefully that will allow me to limit the field of view of these little guys and get decent signals to compare. Here's our first demo of the custom HPA system for the needler. Lots of CNC aluminum parts, plus 3 more you can't see inside the cylinder. Custom designed and printed resin chamber, and all the other parts custom as well. We're going to demonstrate it here using our air compressor and an air gun hooked up to the HPA line. So today's test runs at about 110 psi, a little bit short of what we'd use in the field, but good enough for our demo. What we're looking for is the nozzle to come in here, push the needle in, make a seal, and propel it down the barrel. So let's take a look. Oh yeah! How about that? You heard they're going out of the chamber nicely down the barrel with plenty of force. Alright, we're finally ready to test our glitter emitter. So we've got our 2 hoses on the front. When installed, they'll come out on either side of the barrel, enabling our glitter to be backlit by lasers and LEDs. We got our chamber filled with blue marking chalk for this test, and of course our feed line. And we've got an air gun adapted to fit our HPA lines that will tap off of the main valve to feed the glitter emitter. Here we go. 1, 2, 3. Oh yeah, might have to dial that back a bit.